All right.
Okay. So I have no idea if I did this right, but I guess I used the distributive property to multiply negative 6x squared to all the numbers in the parentheses. So I said that negative 6x squared times x squared was negative 6x to the fourth.
Excellent. That is exactly right.
And then 6x, negative 6x times negative x is just positive 6 x squared.
X squared times x to the first.
I thought it was just that because you're multiplying a negative times a negative, and so, well,
And when we're multiplying monomials, we will be adding the exponents. So 2 plus 1 is
6x to the third, not
there you go.
positive 6x to the third.
Yep.
Okay. And then 6x, negative 6x squared times negative 12 would be positive 72x squared.
There you go.
So
Yeah, you did it perfectly. That's it.
and then simplifying it, I did that too.
Well, hold on a second. So to simplify polynomials.
Oh, I guess I couldn't anymore.
Right, we can't anymore because we have x to the fourth, we have x to the third, and we have x squared. None of those are exactly the same. So therefore, we can't combine those whatsoever. We are done. I know it's not the most satisfying answer in the world, but that's as far as we can simplify it. All right, you did a fantastic job. So,
thank you.
You're welcome. Number 16 is actually exactly like number 13. No differences. I could have written this. I could have written it as 2a times 4a squared minus 5a minus 7. But, you know, sometimes we like to do multiplication like this. There's no difference between what I wrote here and this problem here. So is there a brave soul willing to try this problem?
I volunteer as tribute, Olivia Carter.
Olivia Carter, tribute.
Okay, so I said 2a times 4a to the power of 2, and I got 6a to the power of 2, but I wasn't sure if it was 6a to the power of 2 or 6a to the power of 9.
Well, what is 2 times 4?
Oh wait, no, not 6, sorry, not 8.
8.
Sorry, oh my gosh.
It's okay.
A to the power of 2.
Well, hold on a second. A to the first times a to the second is a to the third, because we add the exponents when you multiply monomials. Okay, so you're doing really well.
And then I did 2a times 5a, and I got 10a.
And a to the first times a to the first is a to the
Second.
Excellent. And we have a positive times a negative.
So it's negative 10a versus minus.
Yeah.
Okay.
And negative and minus, it's interchangeable because subtracting a positive is the same as adding a negative. So, all right.
And then I did, and then I did 2a times negative 7, and I got negative 14a, and we also do the power of 2.
Well, we have a to the first times no other a's.
Okay, so it'd just be 14a.
Yeah, it would just be 14a. And we have a to the third, a to the second, a to the first. Are we able to combine those things?
No.
Nope. So we are done. All right. Do we have a new volunteer for number 29?
I volunteer as tribute, Riley.
Okay, Riley.
Okay, so I started with distributing the 5x to the second power to the 2x minus 1, because that's the parentheses. So 5x to the second power and then 2x, that would make it 10x to the third power. And then 5x to the second and negative 1 would be negative 4x to the second power. Wait, sorry, I don't know why I said that. 5x to the second power, negative 5x to the second power.
All right, good catch.
And then I did the next one, which was 2x times 3x to the second power, which is 6x to the third power.
Now, is that going to be a positive or a negative?
A positive because it's a negative 2x times a negative. I don't know what I was thinking.
Oh, no worries.
So it'll be a negative. I'm losing it, sorry.
It's early, it's early.
So it's going to be negative 6x to the third power. And then the next one would be positive 8x because it's negative 2x times negative 4x. And then I have a question.
Hold on, we're not done yet. X times x is x to the second. Okay.
So I have a question now. Would I put an addition sign in between them or a subtraction sign? Like how, or is this as simplified as it gets and how it's supposed to look?
I'm not sure I understand your question fully. So I'll try to answer it. And if I don't answer it, please let me know that I was way off base. So at this point, for the signs, the way I like to think about the signs is this. We have a positive times a positive, so that's a positive. A positive times a negative creates a negative. Because of this negative out front, we have a negative 2x, so this whole thing is negative. A negative times a positive is a negative. A negative times a negative is a positive. Now, in terms of simplifying, we have to look, do we have any terms that are identical? For instance, yes.
No.
Well, do we have any other x to the thirds?
Yes.
Yes, we do. So that means we need to combine the similar terms. So what is 10x to the third minus 6x to the third?
4x to the third.
There you go. Perfect. Negative 5x squared plus 8x squared is?
3x squared.
And that's a positive, so we have to put...
Positive.
And now we're left with x to the thirds and x squareds. They are not the same thing. Therefore, we cannot combine it any further.
So when I'm simplifying it and I did the first simplified, after that, do the parentheses just not apply anymore?
Okay, so with the parentheses are there to show that you have this negative 2x multiplied to everything inside this parenthesis. So as soon as you do this distribution, you have taken care of the need of the parentheses. So as soon as you do that as soon as you do that distribution, then the parentheses have no more purpose. So that's when they get dropped.
Oh, okay.
And same.
Thank you.
No, that's a great question, and that's the same thing here. As soon as we distribute the 5x squared to everything in the binomial, that's when we can drop the parentheses, because the parentheses are there to show that the 5x squared is being multiplied by 2x and the negative 1. So that's why there's no parentheses in the second step, because we've taken care of them already. Does that help? Okay. All right. Finally, for the last one, I'd like to get today's investigation. So I'm just going to do this one really quickly. 3 to the 4th power is 3 times 3 times 3 times 3, which is 81. S squared to the 4th. Well, this is when we multiply. When we have powers of monomials, that's when we need to multiply the exponents. So that's why we have s to the 8th. T to the 1st to the 4th power is t to the 4th power. And so there we have it. Are there questions on this warm-up?